All right, so for our first example problem, what we're going to do is we're going to make a circuit that has nothing super crazy. We're going to do a series circuit that has 3 resistors. And actually, you know what? I'm going to draw this a little bigger. So I'm going to draw it nice and big. So maybe if you want to take up like half a page, since this is your example, we got 1 resistor, we got 2 resistors, we got 3 resistors. And what I'm going to say is this battery, we'll say, has 12 volts. Okay, 12 volts. We're going to call this R1. We're going to call this R2. Call this R3. And what we're going to do is we are going to put all of the variables for each one of these components. We're going to identify them. So every component has a resistance. Every component has a voltage, and every component has a current. So we're going to do that, right? So I haven't given you any other numbers yet. We're just putting these in here. What I am going to do is give you all the resistances here in a little bit. So VR2, IR2. Man, I cannot spell today. 2. R3, VR3, IR3. Make those all equal. Signs. Alright, so what I'm going to do is I'm going to say that resistor 1 is 1,000 ohms. I'm going to say resistor 2 is 1.2k ohms. And I'm going to say resistor 3 is 500. I also told you this was 12 volts, so we're going to call this one VT. So anything with the battery is going to be your total. So we're going to have an RT, a VT, and an IT. So if you think back to our parallel circuit, series circuit table, right? We said in a series circuit, resistance total equals R1 plus R2 plus R3. We said VT equals VR1 plus VR2 plus VR3. And we said that IT in a series circuit equals IR1 equals IR2 equals IR3. Alright? So we're going to use all of that plus our Ohm's law to solve for all of these missing numbers. And you might say to yourself, wow, that's a lot of numbers. It's going to take a while. It's actually not going to take as long as you think, because some of them are equal. So once we find one of them, we can use them everywhere. So what I want you to think about is this. Every time you want to do like whole circuit-wide calculations, you're going to use these formulas right here. If you want to do component calculations, like I want to do calculations to that, you're going to use Ohm's law. Okay, again, if you want to do component level calculations, you're using Ohm's law. If you want to do circuit or system level calculations, you're going to use your rules up here for series. Okay, so get rid of those, and let's start. What I like to think about, I like to think of circuits, the way I was taught was, think about it like a puzzle, right? Every time you put a puzzle piece down, every time you solve a portion, it gives you some more information that you can work from. Okay, so we're going to look at everything we have, and first we're going to do any conversions, right? So I see here we have 1,000 ohms, that doesn't need to be converted. 500 ohms, that doesn't need to be converted. 12 volts doesn't need to be converted. We're looking for everything to be in standard. This is not in standard. So 1.2 k ohms, we know that 1.2 k ohms is actually 1,200 ohms. So we're not going to use the 1.2, we're going to use the 1,200. Okay? All right. So first part we're going to do is we're going to see what we can do. Well, we have voltage. We have voltage total. Voltage total says that they all add up. Doesn't say they're all equal and they add up. They just add up. So they're not like R1 and R2 are not the same number. R3, R2, and R1 are not the same number and they add up to 12. It just says that they all add up to 12. So that doesn't help us. But we do have all the resistances, right? We have resistance 1, resistance 2, and resistance 3. We have 1, 2, and 3. We know that those add up to the total. So let's do that. 1,000 plus 1,200 plus 500. Oh, we get 2,700. So all I did was I did R1 plus R2 plus R3 to get RT. R1 plus R2 plus R3, R1, 2, and 3. I get 2,700 ohms. I'm going to leave it right like that. I'm not going to change it. I'm not going to convert it. I'm going to leave it right as 2,700. Great. Now, what that did was us calculating that answer opened a door for our next thing we can do. Again, it's a puzzle. Okay? So I can't do any more of these because I don't have enough information. But I do have now RT and VT. And I told you, if you want to do circuit level calculations, you can do Ohm's law. Well, I would ask you, if I give you RT, if I give you R and I give you V, R and V, can you find I? And your answer would be yes. All right, so we're going to do that. We're going to say I equals V over R. I equals 12 over 2,700. Alright, so we're going to do that. And I'm doing it with you. So I get 0.0044. And that's amps. Great. Now, what I can do is, if you look at this guy right here, what does that tell us? That tells us that all the currents are equal. So guess what I can do with this number? I can just take that number and I can put it everywhere because it's all equal. And some of you are probably seeing some of our next steps. If we have those, what can we do? Well, can we do Ohm's law here? Yes. Can we do Ohm's law here? Yes. Can we do Ohm's law here? Yes. Because we have 2 out of the 3 of these. So do we have a formula that can solve for V? Sure. V equals I times R. I times R will give us V. I times R will give us V. I times R will give us V. So let's try that. So we're going to do V equals 1,000 times 0.0044. And just to make sure that I am good, and just so we're clear, I rounded a little bit on that 0.0044. I would encourage you not to round if you have a calculator that can handle it. Don't round until the very end. So I get about 4.4 volts. Awesome. So let's try this one. 1,200 times 0.0044. 1,200 times 0.0044. I get 5.28 volts. And this one, 500 times 0.0044. Oops. 2.22 volts. And we can check to make sure everything is correct, because if we take our voltages were the last things that we did. So take them, and what do we know? We know that they all should add up to the total. Well, does 4.4 plus 5.28 plus 2.2. So I get 11.88. So where that comes, it's close to 12. So where was the difference? Well, probably in our rounding, right? 2.22 we rounded a little bit. 5.28 we rounded a little bit. 4.44 we rounded a little bit, and our amperage we rounded. So we're there. We made a little bit of a rounding. We rounded a little bit too much. Okay, so just understand that, right? But then the nice thing about checking at the very end with one of your formulas, whatever formula you're going to use, is it doesn't check just the numbers you did. It checks everything, because everything's based off of everything else. And the last part is everything that we've just gone through, everything I've showed you, applies to series and parallel, which means if you take the puzzle thought process and you just break it down, you draw out your circuit, you write your 3 variables for every component, and you just treat it as a puzzle, you can find everything. Okay? And then the last part is we want to make these better answers, right? So 0.044 amps is not the best answer. A better answer would be 4.4 milliamps, right? For all of these, right? So this would actually be like 4.4 milliamps. 4.4 milliamps. 4.4 milliamps. Ideally, that's how you would want to be. You would want it to be better, a better answer. 5.2 is good, 4.4 is good, 2.2 is fine. Okay? So take what I've taught you in terms of just dissecting a problem and apply it to any problem we give you, whether it's got two resistors, 3 resistors, 10 resistors. Use the same thing and apply it if you have a parallel circuit, right? Just slowly chip away based on what you have and what formulas you're going to use. Okay? And if you have any questions, feel free to ask.